So I want to look at this table. First question. It says determine the type of function. Is it a function?
Yes.
How do you know?
Because each x value has its own unique y value.
Yes, each x value goes to exactly one y value. It has its own unique y value. It is a one-to-one. Every y value came from only one x value. Nice observations. Now I want to know what type of function it is. So like if I were to graph it, what shape would it make? It looks like it might. I need to look at the numbers, at the inputs and outputs, and see how they're changing to determine what kind of function it is. So first I'm going to look at the x's. What's happening to my x's as I move across the table? It's going up by 1. It's really important that we know how much it's going up or down by, because if my x's aren't changing by a constant amount each time, then I can't look at the table to make a determination on the type of function. I need my x's to be changing by the same amount. It doesn't have to be 1s, but it's got to be the same. What's going on down in the bottom with those y's? They're going down by how much? 5. 12 minus 5 gives me 7. 7 minus 5 gives me 2. 2 minus 5 gives me negative 3. All the way across. When my x's are changing by the same amount each time and my y's are changing by the same amount each time, we say that it has a constant rate of change. What kind of function has a constant rate of change? Linear function. Another way to talk about a constant rate of change is to call it the slope. Y equals mx plus b. You guys are giving me so much good stuff. I'm like losing my own train of thought, which isn't a bad thing. So determine the type of function. This is a linear function. So y equals mx plus b is the form that we write linear functions in. What does the m stand for in y equals mx plus b? That's the slope. That is our rate of change. What does the b stand for? Y-intercept. Looking at the table, what does a y-intercept always look like? Because this is where we start graphing. Yesterday, when we identified our y-intercept, we immediately went up or down on which axis? On the y-axis. And then we put our first point there. Writing those ordered pairs, if I'm on the y-axis, what will always be true about the x part of that ordered pair? It will always be 0. It's going to be 0 and then some number. Well, I've got a table with a bunch of x's and y's that are on this line. 0 and 12, because the x is 0. So here's our y-intercept. What number are we going to put in for b? What'd you say? 12. You're looking at something else, and I like what you're looking at. This is my y-intercept. So I know what I'm going to substitute in the place of the b. I still need my slope, my rate of change. What is slope? Rise over run. Close. Rise over run.
Run 1.
Yeah. Which axis goes up and down?
Y.
The y-axis. So I'm looking at how much my y's changed by each time. Yes, this is the change in y, which was -5. Over run is which way? X-axis. So it's going to be divided by the change in my x values. That little triangle that I'm putting there, that's a Greek letter delta.
That was how mathematicians
It's how mathematicians have shorthand for change in, so that they don't have to write those words out over and over and over and over and over each time. So that's what that little triangle means. It means change in. Can I divide -5 by 1 and get a whole number?
No. Oh, wait, yeah.
What is -5 divided by 1? -5. So here's my slope. This is our m value. So I'm ready to write my equation. Question though, when you look at this table, what are the variables that it says we're using?
GX.
Yeah, we have x for our input, and they've used function notation for the output. So when I write my function rule, I need to use the name that they chose right here. So instead of y equals, I'm going to write this as g of x equals. What did we say our slope was? -5. What goes next to the slope? X. And then I want my y-intercept, which is what? Plus 12. It was a positive 12, so we put plus 12 here.
So in this case, do we wait till our question C to do the -1 and
Mm-hmm. Yes. This one, since we got this rule right from this table, it just uses this function notation. We do that little -1 when we've undone all the operations. So we've switched our x's and our y's, and we've undone all those operations. That's when we would have the little -1, because that notation means, hey, this is going to undo the other one. It's the inverse, yes. And I want to do that in part C. What's the first thing I do when I want to find the inverse?
Replace the function
Yes.
notation.
We're going to replace that function notation. So instead of being a g of x, I'm going to write y equals -5x plus 12.
Then you switch the variables.
Then we switch our variables. What are the variables we have here? X and y. X always means input, and y always means output. So I switch those because my input and my output are switching places.
So x equals -5y plus 12.
Absolutely correct. X equals -5y plus 12.
And subtract 12 from each side
Yes, tell me why.
because you have to get the y alone.
We have to get the y alone, and the whole point of this function rule is to undo. So I want to undo all these
Trying
operations.
to do the opposite of adding 12 and subtracting 12.
That's exactly right. If I want to do the opposite of adding 12, I need to subtract 12. So x minus 12 equals -5y. Am I done undoing all the stuff?
No, you have to divide.
I have to divide, because what's happening right now? Multiplication is what's happening right now. And I want to undo that.
And you have to cancel out the -5s.
Yes. I'm going to divide the right side by -5. What do I divide on the left side? To x and the 12. Every piece I see on the other side gets divided by -5. X divided by -5. This is the same as -1/5 x. If I'm dividing, it doesn't change into -5x, because that means multiply. But if I have 1/, fractions always mean divide. And then a negative divided by negative is what? Positive. So this would be plus 2.4, or you could leave it as a fraction since it doesn't come out to be a whole number.
Equals y.
Equals y. I'm going to write down the other option underneath this. If you want to change it into decimal form, then you would need to change both parts into decimal form. We don't want an equation that has fractions in one spot and decimals in the other. So this would be -0.2x plus 2.4 if you were going to write it in its decimal form.
Okay.
Now that we've got our inverse rule, now I need to name it so that I know every time I see it, hey, this is the function that undoes the other one. What was the name of the other one?
Linear function.
That's what kind. You're correct. What was the name of it? What did we start the equation with? G of x. So what name can I give this one so that I know? G inverse of x. So G inverse of x is equal to everything that was on the left side. So negative 1/5 x plus 12 over 5, or if you wrote that in decimals, you would have G inverse of x.
Minus, you don't do the y.
Correct, you don't do the y anymore. The function notation takes the place of the y. So I'm okay with either one of these for your inverse function notation. If you pop numbers into your calculator when you're dividing, like 12 over 5, and you get a pretty decimal, 2.4, that stops on your calculator, right?
Mm-hmm.
If that happens, I am totally okay with you writing things as decimals. If you put it in your calculator and it doesn't stop, it runs off the screen,
You have to do the little.
still need you to write it as a fraction in that case. Don't change it into decimal form if it runs off your screen. Because a lot of times we're going to be using these inverse rules to find values. And if you change it into decimal form, you have to round it.
Also, if you did the little repeating thing on top, with it, brackets, you have to change it.
That's exactly right. All right, are you guys okay with this? Does this feel, after yesterday's lesson where we first learned about the switching and stuff, does it feel a little bit more familiar? Okay, hopefully it feels a little less foreign. We're going to practice with 2 more problems before the end of the period. So let's look at this story problem here. All right, so we have Hooke's law. Hooke's law is something from physics that describes what happens when you hang a weight off the end of a spring. So I'm going to pretend for just a minute that my stylus here is a spring. It's all this coiled up metal. If I hang a weight off the end of it, what's going to happen to it? It's going to come down. What happens if I add more weight to the bottom? It's going to keep dropping down further. That's what Hooke's law is talking about. They use fancy words to describe it, but that's what they're saying here. The length that a spring stretches to is proportional, which means we can predict it without having to do the experiment over and over, is proportional to the weight attached to the spring. For one scale, this is the equation. And right at the beginning, that's not a number 1, that's a letter L. I hate it when they use lowercase l's in equations, so I usually write them either as cursive or capital. Because other words, they just look like 1s to me.
So this would be kind of like y equals mx plus b. You have y.
Very similar, yes. L is the total length. And what does W mean?
Wait,
W is the weight.
and it says in pounds.
So before we actually go through the process of finding this inverse, I want to remind you of when we were doing the tables the other day. So when we had the tables that talked about months and hair length, do you remember looking at that one?
Yes.
When we wanted to make the inverse table, what did we do to those labels? They also switched. The input and the output switched, and so my labels switched with it.
Yeah, because it wouldn't make sense if we had it hair length is 0 point something.
Exactly. So I'm looking over here at my steps to find an inverse. First of all, do I need to do this first step? No, this isn't written in function notation, so I don't need to do that.
But you can't switch the variables.
I can, however, the reason I switch the x and the y is because I'm going to take the numbers in the x and the y columns and I'm going to switch them around. But x always means input, and y always means output. In this case, do my letters just mean input and output, or do they have specific meanings? L means length, W means weight, not just input and output.
So we need to subtract 3.
Yep.
Both sides.
So I'm not going to switch my variables here because they have meaning. If my variables have meaning in context, the W means weight, the L means length, I won't switch them around. Because to switch them around would mean to make W go with the other numbers, and to make the L go with the other number. Like, I want to keep them with the numbers they describe.
So minus 3 on the 0.5 and W.
Yep. I do want to undo all the operations, so you're absolutely correct. We're going to subtract 3 from both sides. So now I would have L minus 3 equals 0.5 W. Have we undone all the operations? No. Normally I would say yes, we need to divide, but 0.5, is that a whole number?
No.
What's it the same as?
0.5 over
1/2. 0.5 is the same as 1/2.
so 1/2.
So something has been cut in half, and I want to undo that. How do I undo something being cut in half? Multiply by, not by the square, by 2. Something that had been cut in half, like say your money, if you had $5 and you cut that in half, now you have $5. If I double it, if I multiply it by 2, that gets you back to where you started, right? So I'm going to multiply both sides by 2. What would I multiply by 2 on the left?
The L and the negative 3.
The L and the negative 3. So I'm going to have 2L minus 6 equals what? What's half of 2? 1. So I have just 1 W over here.
So, but you can't you take off the W? I mean the 1.
Yes, you can write it as just W instead of a 1W. Did my original function rule have function notation?
No.
Then do I need to use inverse function notation here? No. So I'm not going to do that step either. The only thing I'm going to do when my variables have meaning is undo all the operations that have been done. So this would be W equals 2L minus 6.
So 2 minus 6 equals
Yep, 2 times the length minus 6 equals the weight. That's absolutely correct. Part B. If I take a melon, I don't know what kind of melon, maybe it's a watermelon, maybe it's a cantaloupe, maybe it's a honeydew, I don't know. It's 5.5 inches long. So yeah, it's probably not a watermelon unless it's one of the itty bitty ones. Have you guys ever seen those itty bitty watermelons at the store? Yeah. Or honeydew or cantaloupe. What would I do with that length to try to figure out the weight? Yes, we're going to sub 5.5 in the place of L. Since I'm substituting it in and the W is on the other side, this is my input. Once I substitute it in, I'm just going to perform those operations and get my answer.
You get 5.5 or when you do 10.2 or something like that.
So I have 2 times 5.5 minus 6. When I'm working with things like 0.5 or 0.25, I usually find it really easy to think about money. If I have $5.50 and I double it, I multiply it by 2, how much do I have now?
Oh, wait.
$5.50, and I'm going to double it.
$11.
$11. So I have W equals 11 minus 6. What is 11 minus 6? 5. W equals 5. 5 what? This is a story problem, and W has meaning.
5L.
What does W mean again?
Weight.
Weight. How are we measuring the weight? In pounds. So 5 pounds.
Is it safe to assume if they don't say how we're going to make a weighted, then we just say it's pounds if it's like a food item? Because on here technically it doesn't say you place a melon on a scale and the spring stretches to a total of 5.5 inches.
It says 5.5 inches, and up in the original question stem it said that the weight was being measured in pounds. If they don't give you units in the stem or anywhere in the problem, then you could make up your own units. I would be okay with that, whatever you think sounds reasonable. Or you can leave off the units if they don't give them to you. You guys okay with this so far? Cool. I want to look at one more problem. Jalen purchased season tickets to the Indianapolis Colts games. The ticket package requires a one-time purchase of a personal seat license costing $1,200 for 2 seats. A ticket to each game costs $70. The cost, C of X, in dollars, for Jalen for the first season is C of X equals 600 plus 70X. So I want to talk about this for just a minute. Are they using function notation in this problem?
Yes.
Yes. What is our function notation?
C of X.
C of X. What does the C part of it mean? Not Colts.
Cost.
Cost. What does the X mean? It is my input. What is it measuring? Read the problem. Number of games. So I'm going to think about this table here. So X on the input side is number of games.
So that means this can't come out to an even number or a negative number.
Correct. What is the output telling me? My Y variable. Cost. Yes, you're absolutely right. That's where they used the function notation. Function notation always gets used for my output. I want to find the inverse function rule, and we're going to write this using inverse function notation. So the first thing I want to do to find an inverse rule is what? We're going to get rid of our function notation, right? And replace it with what? Y. So I'm going to have Y equals
But you have to keep the X. Oh, no.
600, yes, you're right, plus 70X. X and Y mean input and output, right? Do they have special meaning in this problem, or is it just input-output?
Special.
Just input-output. When my letters specifically tell me something. So like L for length and W for weight. Here, X, that's just X. It means input. They told me what it meant,
But it's not special.
but it's not special. That's absolutely right. So after I replace my function notation with Y, what do? I'm going to switch my input and output variables. X equals 600 plus 70Y. And now we're going to go through the process of undoing every single operation so that this function will undo all the operations. Okay, so I'm having some disagreements. Do I subtract the 70 or the 600? Does the 70 have any other operations going on with it? Multiplication. Then I can't touch it yet. If there's another operation happening with it, I can't touch it. So I'm going to subtract the 600 from both sides. So I'm going to bring that up and around because I'm starting to run out of room here. So I would have X minus 600 equals 70Y. You told me the 70 and the Y are being multiplied here, so what operation will undo multiplication? Division. I'm going to divide by 70. X and the negative 600. You're absolutely right.
Oh, this was the next 600.
So I would have 1 over 70x minus, when 7 is in the denominator, that's messy, isn't it? But they both end in 0, so what could I divide them both by?
10.
I can divide them both by 10 when they end in zeros. I can divide them both by 2's as well, but I can divide them both by 10. So this becomes 60 over 7 equals y. Do we have y alone?
Yeah.
Yes. Did we use function notation at the beginning? Yes. So I do want to name this inverse so that I know this is the one that undoes what the other one did. What should my inverse function name be? Yep. C with the little negative 1 because it undoes things. So C inverse of x equals 1 over 70x minus 60 over 7. There's my inverse function rule. You are correct. So now I want to talk about the meanings of the input and the output here. If I have switched around those meanings, what does x mean now?
X means
So I'm coming over here. I'm looking at like the table. Input used to be number of games and output was cost.
Now it's cost.
Now my X, my input is cost. And what does my output mean?
Number of games.
Number of games. This is for my inverse. Now that we've found that equation, I want to use the equation that we just found in part A, and I want to know how many games Jalen attended if his total cost for the season was $950. Where do I put that $950?
In your B.
Is it an input or is it an output for my inverse? It's the input because it's the cost. So this is cost. That is the input of the inverse. So I would have C inverse of 950 is equal to 1 over 70 times 950 minus 60 over 7. Back here when we divided by 70, x over 70, and so I wrote that as 1 over 70x. If I multiply a number to a fraction that has 1 in the numerator, that number just moves up into my numerator. So this is 950 over 70. Minus, I need to have a common denominator here, so I'm going to multiply these by 10 again so that I can get that common denominator. Now I can subtract those two numbers, 950 minus 600. I think you were right the first time. 350. So I'm going to have 350 in my numerator and 70 in my denominator. Can I divide those? Yep, 350 over 70. I can divide them both by 10 for sure, right?
But since we know 7 and 35 are multiples.
Yep. What'd you say? 5, yes. Because I would have 35 over 7, and so we get 5. 5 what? The output of the inverse function tells me what? Number of games. So this would be 5 games. I only have one more question for you guys before we're done with this. Something that's been eating at my brain all the way since the beginning of this problem. It said that the personal seat license was $1,200 for 2 seats. So where did that 600 in the equation come from?
600
Split in half.
times.
Yeah.
Since it's set for 2 people.
Yes, 1,200 was for 2 people.
So for 1 person it'd be 600.
So for 1 person it would be 600. Where did the 70 come from in the original
Game
equation?
cost. So it's 70 for the game itself, 600 for the personal seat per person.
Yes. So the starting cost before he decides how many games his season tickets are going to be for is $600. And then 70 for each game after that. Absolutely correct.
Isn't that how we know it's a function? No matter what you can predict that
Yep. We know it's a function because of that. All right, guys. Homework number 2 for this unit. Unit 3, homework 2 is due tomorrow morning.